Understanding the flow of oxygen through an anesthesia machine and breathing circuit is essential for mastering the system. Full knowledge of the machine will also help keep the patient safe and provide insight while troubleshooting any complications that may arise. To understand this complex machine more easily, we are dividing it into 3 separate systems: oxygen delivery, breathing, and scavenger. We'll start with the oxygen delivery system, which is how oxygen is prepared for patient use. Our oxygen supply is usually a compressed gas cylinder connected to the machine or a wall outlet connected to a supply elsewhere in the building. The pressure of this oxygen is anywhere up to 2,200 pounds per square inch, or PSI, which is too high for a patient's lungs. Because of this, a pressure regulator connected to the supply reduces it down to 40 to 50 psi before it even enters the machine. From there, it travels to the flow meter, which further reduces the pressure to 15 psi. Now that the oxygen is at a safe psi, a vaporized anesthetic liquid can be added to it, so it travels to the anesthetic vaporizer. The oxygen and now anesthetic gas mixture, also called fresh gas, then flows to the common gas outlet. Looking to the real anesthesia machine now, we can follow the path of the oxygen from the pressure-regulated supply to the flow meter, to the vaporizer, and through the common gas outlet. From here, we enter the breathing system, where the fresh gas is delivered to the patient's breathing circuit and inhaled. Once the patient exhales the gas, it travels through the exhalation tube of the breathing circuit to the carbon dioxide absorber, so the gases can be rebreathed by the patient via the reservoir bag. The manometer measures the amount of positive pressure in the entire system, including the pressure in the patient's lungs. Most of this occurs in the manifold area of the machine, but we can see on this image the blue tube cased inside the clear tube of the breathing circuit. Fresh gas to be inhaled travels down the blue section, and the exhaled gas travels up the clear section. These exhaled gases warm the inhaled gases of the inner tube as the patient breathes. Then it gets cleaned of carbon dioxide and can travel to the reservoir bag and back to the patient through the manifold. This brings us to the scavenger system, which is where the excess expired gas that is not rebreathed by the patient is safely removed from the anesthesia machine. This waste gas travels through an adjustable pressure limiting valve, also known as an APL valve, or an occlusion valve, depending on the setup, traveling then to the scavenger system. The waste gas travels through a large corrugated hose, shortened here for ease of understanding, to a wall outlet and is vacuumed away by an active scavenger. An alternate path used during regular anesthesia machine operation is when flushing the system of anesthetic gas using the oxygen flush valve. This path bypasses both the flow meter and vaporizer, so the oxygen running through here still has an unsafe pressure of 40 to 50 psi and should therefore not be used when connected to a patient.